All right, well, the star of one of my previous videos is back. This is the power supply that I repaired, and that video got something like 12,000 views on it, which I'm kind of ashamed of because my camera work in that video was absolutely terrible. But anyway, I mean, that video still gets the point across, at least in my opinion. People have commented the camera works bad, but yeah, it still works. But anyway, this blew up this time. Well, not really blew up. Started arcing on the inside. It's not capacitors this time because it was actually working. So anyway, here's the story. I started a 3D print, which I usually record those for the time lapses. I'm not sure that anybody really cares that I put those in the videos, but anyway, when I do that, I turn the studio lighting on, or what I call the studio lighting. It's really just a bunch of LED strip, but that's what this supply is powered to. Actually, you can see the lights, some of them right there. Anyway, and not that long after I started or turned the lights on, I started smelling something burning, and I thought it was just, plastic on the 3D printer at first, but it had a different smell to it. Actually, still don't really know what that smell is. It doesn't smell like burning electronics. It just smells hot plastic, maybe because this was sitting on carpet. That's what I was smelling. That might be why. But anyway, I started to smell that, and I started kind of moving around trying to see where it's coming from, and I realized it was coming from underneath the table. And I didn't shut it off at that point. I thought, okay, maybe it's run a little bit hot. I put my hand on it. It's fairly hot, but it always gets hot. It's a fanless power supply that's rated at like 12 amps. Never started making smells though. I actually checked the voltage on the lights. It seemed reasonable. It didn't have any AC ripple on it or anything. It didn't have anything measurable by my little multimeter anyway. And then after a while, I was still sitting in front of the computer, thankfully. And thankfully I didn't leave it alone. The lights flickered once, and then about 30 seconds later they started flickering again. And I looked down, and this thing's got a blue arc in it, or it's every couple seconds it has a little arc coming across somewhere up in the front, in that sort of section. So we're gonna take this apart. We'll see what happened, or hopefully we'll see what happened. I do apologize because that 3D print's still running and it's probably making quite a bit of noise. The fan on that thing is really, really loud. See if I remember how to take this thing apart though. Remember, it's not horribly difficult, but there's a few screws you have to get to. Actually, might not be that hard to get the cover off if I remember right. Let's see. 2 screws is all. It's actually still a little bit warm. It wasn't hot to the point where I couldn't touch it, but it was close. I unplugged it and then I just grabbed the thing and took the wiring off. So that's it without the outer jacket on. I believe it was from somewhere up here it started to arc over. Oh wait, that right there is your problem. The NTC's got a bunch of cracks in it. Let's see if I can get in close on that. Alright, we've got the macro mode on, which doesn't look very good now, but when I bring this in close we should be able to see it. So that is the part that blew up. That is an NTC, so that's what's used for Inrush current limiting. And you can see there we have giant cracks in it. A nice white mark on the bottom. So that's what was arcing over. These capacitors seem to have held up okay. They're actually slightly warm as we speak. Someone did point out with this that, and now I've got the macro lens on, so I'm not really going to be able to show you, but someone said something about with this over it like that, I probably should have put a piece of electrical tape or something over these caps because they're a little bit taller and they do come really close to the top of this, so if something would have pushed down on that, it would have probably caused an issue with the grounded metal case, but thankfully nothing got dropped on it, so those actually seem to have held up okay. So our only issue here is the NTC, though I don't think this is really worth repairing at this point, or I'm not going to bother to fix it because I don't think I have another one of these to replace it with. Yeah, there goes half of it. Here we go again with the bad camera work. Zoom out a little bit maybe. So yeah, there it is in 2 halves. There we go. That's the problem right there. I don't know if I mentioned this before or not, but right now the lights are actually running off of that lithium battery pack project I did forever. So battery powered room lighting probably won't last for all that long. But anyhow, that is our messed up part. Let's see if it smells like what I was smelling. Not really, actually. But that's definitely the problem. I'll go ahead and cut it out of there. Stuff's still pretty hot in here. I'm not sure how common failures of NTCs really are. If that's a big thing or not. So let's get the macro lens back out and I'll take a look at the inside of this since it's split in half. Alright, so I've got my NTC halves kind of propped up here just so I can get the macro lens to focus on them properly, but if we zoom right on in here, you can get an interesting look at the structure inside. It almost looks like some type of crystal formation. I'm not sure if it is. And I'm not entirely sure what these are made out of, if it's carbon or if it's some kind of silicon or something like that. I'd imagine some kind of carbon. I'm not real sure though. But just as some kind of scale as to how big the little pits and stuff in here. This is a piece of 1mm solder, which I'm going to lay right down on top of it. So that might give you a bit of an idea. And I actually have a piece of 0.5mm solder as well that I can put on here. That's what the 0.5mm solder looks like. So anyway, that's what the inside of this thing looks like. That's the other half. And the other piece is probably just disintegrated and went off somewhere. And of course, when something like this happens, the fuse won't blow or anything like that because it's not technically overloaded. It's just arcing, which is kind of a dangerous fault. And it is odd because the circuit breaker to this room actually is an arc fault breaker, so it should have theoretically tripped, though I'm not entirely sure what the circumstances are to cause one of those arc fault breakers to trip. So anyway, could this be fixed? Yes, you could put in a new NTC. Technically speaking, you could probably just short this out and it might work. It wouldn't be safe necessarily, but it might work. Definitely not a recommended thing to go shorting components like this out. So anyway, what this is actually for is inrush current limiting. So what happens is after basically any length of time a power supply sits unplugged, at least if it's designed properly, the capacitors will be drained down by resistors, or they'll drain down over time by themselves anyway. But when that happens, your capacitors are down to 0 volts. And when you go to plug it back in, if you didn't have one of these, the capacitors basically act like a short circuit. Actually, the capacitors act like a short circuit anyway. But this device here makes it so that the short circuit doesn't go all the way back to the wall, essentially. And that just keeps the, because if you had that big current rush, you get a nice spark when you plug it into the wall, which some of these power supplies you still get. But it's definitely not a good thing to be passing that much current through any of the parts that are in between the capacitors and the outlet. For example, the bridge rectifier is in line with that, which may or may not be able to handle that current spike. It depends on where you're at on the sine wave. But anyway, that's not too important. What this actually is a variable resistor, essentially, and I keep calling it an NTC. NTC stands for negative temperature coefficient, which means as the temperature rises, the resistance goes down. So what ends up, or how this works, is it starts at a relatively high resistance. I'm not entirely sure exactly how high of a resistance this particular one is, mostly because it's split in half and I can't measure it. So it does have a marking on the back of it, I think. Yeah, it's 5D-11. You might be able to find information on that, I'm not sure. And then it even says NTC on it. But anyway, what happens is it starts out as a relatively high resistance. You plug it in. The capacitors are going to try to draw as much current as they possibly can. And all that current has to go through this NTC. since all that current has to go through this NTC, and it's a relatively high resistance, it starts to heat up. And as it heats up, the resistance will start to drop. Lower the resistance, the less it has to heat up, and it's eventually going to find sort of a balancing point between the heat that it outputs and the resistance that it's at. It's always going to be a little bit warm. I'm not entirely sure how hot these things will run, but that's basically how it works. And then during normal operation, this thing is more or less a short circuit. So it acts like a piece of wire and just allows the electricity to flow right into the power supply, or it might be like 1 ohm or something like that. It won't be very high. It won't be a very high resistance at all. Which it is kind of odd. This power supply never gets unplugged, so it may still be getting thermal cycled. I will say that, because this power supply does, most of the time it has a very light load, almost no load, something like 20 milliamps or something like that. And then every once in a while I turn on these big studio lights, or the LED strip, not technically studio lights, but anyway, when I turn those on, those things pull a good 8 amps or something like that out of the output. So it may have been thermal cycled, and maybe that's why it cracked, but still it should have been able to take that. Like I said, or like I think I said, this thing only lasted for 10 months in total now. Because it got put in January, so really it's only lasted for 9 months, because right now it's September. It got put in late December, early January, somewhere in there, so we're going to call it 9 months. And in the first month, the capacitors went bad on it. So I'll go ahead and take the macro lens back off, but I do have a video, as I mentioned earlier, on me replacing the capacitors. Now, I do kind of want to address some stuff in that video, because there was multiple things that could have been done differently. One of which, like I mentioned already, is the camera work. I do wish that was better, because when I was actually working on the power supply, I had the camera up on the table, and most of the time I was out of the shot, which was pretty terrible. Pretty terrible camera work for someone that's been doing this for really any length of time. And unfortunately, right now my lights are kind of fading. I'm not sure if I mentioned this or not either, but my lights are actually being powered off of batteries right now, so my lighting is not quite that great. It's being powered off of a lithium pack, which is slowly dying. And I'm going to see if I can go ahead and take the circuit board out, because one of the other things that was mentioned, and I did, when I took these capacitors out, I did a pretty bad job of butchering the circuit board up. I actually did a great job of butchering the circuit board. I did a terrible job of removing the capacitors. So anyway, what ended up happening there is I had to do a little bit of repair. And of course you couldn't see it because the camera shot was bad. I thought I got a close-up of it. Apparently I didn't. I thought I got a close-up of it after I worked on it, but I guess not. Someone mentioned that I must have done a really bad job fixing it, because actually I don't know what this, yeah, I gotta take all these screws out, never mind. But anyway, someone said I must have done a really bad job butchering it because I didn't show the end result. Well, no, I think it turned out okay. Probably better than the original in terms of current handling capabilities. So I don't really have a problem with that. And this should fall out. Yep, there we go. Pieces of NTC going everywhere. So those capacitors, it's definitely not a pretty job, but hey, it works. So what happened was I used one of those little desoldering pump things that actually had the heat on the end of it, and I put too much pressure on it. So I ended up ripping the pads off for these capacitors. And somebody said I should learn to use wick, and he's probably right. And I actually have started using solder wick since then, and have been having better luck than this, anyway, with said solder wick. Though I still end up doing damage sometimes with that. Because really the trick with that stuff seems to be to soak extra flux on it. But I'll go ahead and zoom in on this a little bit. No need for the macro lens, I don't think. But anyway, what I did is I just took little pieces of 18 gauge wire, just solid 18 gauge wire, and soldered it between the pad and all these traces that were already tinned like this. So I didn't have to scrape anything off. I just added that piece of wire and soldered it back onto there. Worked just fine for quite a while. I don't really see any problem with doing it like that, especially considering up here I do believe that this is a factory job. And that's basically just solder blobbed all over it in order to increase the current capabilities. So I figure that this is probably just as good as that. And I probably shouldn't be poking around this, though. I'm sure it does have a discharge resistor right there. I mean, we can short it out. It's not doing anything. One other thing that was mentioned in that video that still kind of bothers me is that the fact that I shorted the capacitors out with this metal screwdriver. Completely metal screwdriver, I just went across it like that. I wasn't touching the board, if I recall right. And that will not actually kill you. I kind of want to make a video about testing that, actually shorting a capacitor out with a metal screwdriver like this. But what people didn't seem to realize is I actually measured those capacitors before I shorted them out. So I don't really understand what the whole big scare was, because I literally put a multimeter across the thing and they were showing 0 volts. I just did this to make sure. And part of the reason why I did that to make sure is at the time, the good old EEV blog multimeter was kind of a new thing to me. And it has this low Z mode, low impedance mode, in other words. And what that'll do is it'll actually, I think it's like 1K or something like that. It varies depending on how much voltage there is. But that is actually a pretty good way to discharge capacitors. Because shorting them out is actually kind of, it's not good for the caps for one thing. They're not really designed to be able to take that instantaneously like that and deliver that much current. It can, and actually will, like capacitors like this, if you short them out, it will probably vaporize a decent little bit of that solder and send it into the air, which is not a good thing because that can go flying into your eyes, little bits of solder. That's not fun. So shorting capacitors out with an all aluminum screwdriver like this is it's also what Big Clive does constantly, which I always think is kind of funny, but I'm not sure I've ever actually seen him have a capacitor that was charged and put a screwdriver like this over it. And this is actually basically the same screwdriver he has, but this came from like a health insurance company or something like that. They literally would give these away. Anyway, in theory, you should be able to short capacitors out like this with a metal screwdriver as long as you're not touching anything and it's not plugged in. You shouldn't have, or you shouldn't be able to get a shock because there's no return path. The only place that electricity can go is through the end of the screwdriver, through one side of the capacitor, through the end of the screwdriver, back to the other side of the capacitor. It can't go back up your arm because you don't have anywhere for the electricity to come back out of. If you had your hand on the other capacitor like this and you had one thumb here and you did this, it would shock you, but as long as you're not touching that board, it should theoretically be okay. And as I mentioned, I measured them beforehand. I just wanted to make sure that they were both completely dead by shorting them, just to make sure. And they had like 6 volts or something on them, nothing dangerous. And I think when I measured them, if that, it was probably lower than that. All right, so there was one other commenter that was concerned about safety that I do remember off the top of my head here. And that was some guy mentioning or telling me that there should have been some kind of warning about how dangerous hooking an oscilloscope up to the output of a DC power supply is. And he also said something about along the lines of, if I don't know why, I should get off of YouTube before I kill somebody. But anyhow, the main reason why I bring that up is I actually want to know why. The only thing that I can come up with is that since it was a bad power supply, known faulty power supply, when you hook up an oscilloscope to it, of course you're grounding the thing, you're referencing it to earth ground. And what could theoretically happen with a bad power supply is that you have AC coming back to the DC side through some component, maybe something shorted out on the bottom or something like that. And you have AC leaking back into the DC side, which could be quite a dangerous scenario, because once you hook that up to ground, the other pin might come live at 120 volts, and then if you touch that, it's, you get shocked off of it or whatever. And really, you shouldn't touch the outputs of anything no matter what. And I had no intentions of touching the outputs because you've got, line in right here, and you've got DC outputs right there. I didn't really want to touch or get my fingers anywhere near any of that. And the other thing that could happen with that, if you had AC leaking and you hook up an oscilloscope to it, if you hook up that ground clip and you get a big spark and it throws your circuit breaker. Other than that, you usually don't have, or from what I understand, of course I'm not qualified in any of this stuff, but from what I understand, the only thing that could allow AC to leak over is sometimes there's a suppression capacitor between the primary and the secondary of these transformers, which could let just a hair sort of trace amount that wouldn't hurt you amount of AC back onto this, because this is fully isolated theoretically, or it should be. It's not like it's a capacitive dropper or something like that. It's a power supply with a transformer in it. Should be isolated theoretically. Like I said, there is that odd chance that it, you know, something shorted out and is allowing AC to get to the other side. Other than that, I'm not entirely sure why that would be dangerous. I've seen people do that so many times. Seems to be a fairly common practice because it's the DC output. It's not like I was probing the AC input or something like that, which would be dangerous with a scope. But anyhow, yeah, the things that you do as demonstrations. Now, there could be some other reason why that you know, could have gone wrong, or it could have caused a big problem or killed somebody or whatever. There could be a good reason for that. There might be some quirk in these power supplies that I don't know about. I'm not qualified in any of this, as I said. But of course, the fastest way to get an answer on the internet is by posting a wrong answer. So here I'm basically saying that it's safe unless something has gone horribly wrong in the power supply, which we pretty much established that it hadn't. Maybe I should have done some more multimeter measurements before I hooked up the scope, make sure I wasn't getting 120 out of the DC, but obviously that's probably not going to happen if these power supplies are designed correctly. But I mean, anything's possible. This thing died twice within a year, 2 different failures. Other than that, I think that was about all. I mean, the biggest complaint with that video was the camera work, but it was basically me taking out capacitors and putting new ones in. It wasn't supposed to be a soldering tutorial anyway. So anyway, that is the death of this power supply. I don't think I'm going to fix it. I don't think I have an NTC, and I'm not going to buy one to fix this stupid power supply that probably, I don't remember what this cost, maybe 20 bucks or something. It wasn't very much. And for now, I'm probably going to go ahead and hack in an ATX power supply and see what I can do with that. So anyway, that ends the saga of this poor old power supply, which will sit in recycling. But anyway, that's about it for now, guys. Bye.